And we're live. This is a differential equation class, and we're in chapter 1 of the book. And we're doing section 1-1. And it has to do with modeling of differential equations. The reason we use differential equations is because they occur in nature. So when radiation decays, it decays due to a differential equation. When bacteria grows, it's growing because of a differential equation. When people die and people are born, it's a differential equation. When I jump out of the plane and fall out of the sky and I pull my parachute, where I am is solved by a differential equation. So a whole lot of things fall in the category of a differential equation. So if I say my acceleration is 2 feet per second on some planet, and it's negative because I'm falling down, then if I'm on some building and I'm 100 feet up and I jump off the building, how fast am I going to be going when I hit the ground? Well, my differential equation says that change in velocity, change in time is my acceleration. I can separate my variables and get minus 2 dt. I can integrate both sides of the equation, and I can get velocity at times t is equal to minus 2t plus some initial condition. Well, if my initial condition before I jumped off the building was 0, then that initial condition is 0. I can say that change in position, change in time is that velocity, which is 2t, minus 2t. Initial velocity was 0, so it can go away. I can separate variables again and say I got 2t dt. I can integrate both sides of the equation, and I can get my position at times t to be minus t squared plus some constant. My position at time 0 was 100, so my position at times t is going to be minus t squared plus 100. And then I ask myself, well, when I hit the ground, I'm at 0, so the 0 would be minus t squared plus 100. T would be 10. So at 10 seconds I'm hitting the ground. My velocity at times t, at times 10, is going to be minus 2t, which would be minus 20 feet per second. So when I hit the ground, I'm going to hit the ground at minus 20 feet per second. And now it doesn't matter. I can do it again, and I can say, well, acceleration, instead of being minus 2 feet per second, is minus 1/2 the square root of t plus 1. I could have all kinds of weird things as my acceleration and do the same thing. Separate my variables and come down. And in fact, when I do my physics classes, the calculus-based physics classes, I never use the formulas. I always start with acceleration as something and solve it that way. On page 3, I have some volume. I have some volume sitting in a cylinder draining out the bottom. That's a differential equation. When I look at, I have some y prime is 2. What does that mean? Does that mean anything? Y prime. If I had y is equal to mx plus b, what's b? Yeah, y, so that's the y-intercept. What's m? M's the slope, right? So this is just the equation of a line. If I go y prime is equal to m, and I say m is 2, then 2 would be the slope. All right, well, that's fine. So I have y prime is equal to 2. So now I'm going to draw the answer. There's an 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 answer. Oh, no. I got an infinite number of answers. where the slope is 2, right? It's not until I get an initial condition that I can use to solve for b that I know I have a particular guy. It's this guy that I'm looking at. So y prime is equal to 2 is in fact a differential equation. And I could say dy dx is 2 if I don't run out of room. And so dy is equal to 2 dx. I can integrate both sides of the equation, and I end up with y is equal to mx plus b. Right? Some constant of integration thrown in. But that's the same thing. Y is equal to mx plus b. That's the same place. Okay, so now we're doing section 1 problems. We're doing all of them until we get bored. Every other even. Do you want me to start on 2 or 4? Okay, hearing nobody in the audience, I'll start on 4 this time. And I'm supposed to show that my differential equation has the solutions shown. Okay, so my differential equation is y double prime is equal to 9y, and I'm supposed to show that the the solution e equals 3 to the x is one of those guys. Okay, so y prime is 3 e to the 3x, and y double prime is 9 e to the 3x. So I've shown that one. And then the other guy is e to the minus 3x. So y prime is minus 3 e to the minus 3x. And y double prime is 9 e to the minus 3x. I've now shown that in both cases those are solutions to my differential equation. It's just that easy. Is that easy? Yeah, pretty much. Skipping 6, going on to number 8, unless there's something else going on. Okay, so I've got y double prime plus y is equal to 3 cosine 2x. And I want to show that y prime, y1 being cosine x minus cosine 2x, is a solution to that equation. Okay, so that's what I'm planning on showing. All right, so I'm going to go and take the first derivative, y1 prime is equal to minus sine x minus 2 plus 2 cosine sine x sine 2x, and then y double prime minus cosine x plus 4 cosine 2x. Now, if I take one of those guys and one of those guys, that would be the same as taking y double prime plus y. If I do that, I'm supposed to get 3 cosine 2x. I want to get 3 cosine 2x. So that's what I'm going to do. I got a cosine and I got a minus cosine. They go away. I got a minus cosine, I got 4 cosine, so that's going to give me 3 cosine 2x. Check, my solution works. Okay, skipping, well, 10 looks kind of cool though. Oh, 12 looks cooler though. So we'll go on to 12. We don't want to skip any cool problems, you know. Number 12. So I've got x squared y double prime minus xy prime plus 2y is equal to 0. And I've got that. Oh, I didn't check the other thing for 8 yet, right? I still have another solution for 8 I have to check. All right, so we'll get rid of those things for a moment. Go back to number 8, second part. So I've got y2 is equal to sine x minus cosine 2x. I've got y prime is cosine x plus 2 sine x, sine 2x, and y double prime 2 minus sine plus 4 cosine 2x. I'll do the same thing. I'm going to take one of them. Do you like my notation, or do you? Well, you will, because it's what I use all the time. And the sign goes away, and I have 3 cosine 2x, which checks because I'm supposed to have a 3 cosine 2x. Okay, good enough? Am I going fast enough? Okay, I don't want to, we do continue. All right, so now we're going to do problem 12. And I've got, now problem 12 is interesting in that we never come up with a method to solve this particular differential equation. We have it here with the solutions, but we don't have a method to find them up to chapter 6. So maybe after chapter 6 is a method, but that's just the way it is. Okay, so first we're going to check y1 is x cosine the natural log of x. Okay, so isn't that just Marvy poo-poo, right? All right, so y1 prime is going to be a cosine natural log of x plus x minus, that's a minus sign, I knew it was a minus sign, minus x sine natural log of x times 1 over x. Okay, so we'll rewrite that as cosine natural log of x minus sine natural log of x. All right, so y double prime 1 is going to be minus 1 over x sine natural log 1 over natural log x minus 1 over x cosine natural log x. Okay, well that looks cool. It says that if I were to take x squared times this guy and minus x times that guy and plus 2 of this guy, that when I got done I would get 0. Okay, so that's my plan. All right, so here I've got minus cosine x, and I've got plus 2x. I have minus cosine x. Here I have a minus cosine x. So here I got plus 2 cosine x minus cosine x minus x cosine x. Okay, so that's good. Then I've got minus, which makes it a plus. So I've got a plus sine natural log x, and I've got a minus x sine natural log. So those guys go away. 0 is equal to 0, the problem checks. Okay, cooking with gas. Now we got the other guy to do, and the other part says y2 is equal to x. At least we're not doing hyperbolic sines or hyperbolic cosines yet, right? You see any in the book yet? No, I don't see any yet. I'm sure we will. Section 2. Okay, y prime 2. So I'm going to be sine natural log x plus cosine natural log x. Now, it's my intent to skip as many steps as possible in the math. Okay? If you don't see what I did and don't agree with me, then you have to stop me to put the steps back in. or just flip me off. That's what Andrew would do. But either way, just kidding. This is Andrew, not you. Yeah. Anyway, but if you don't see that that's right, you just stop me and I'll see if I can solve it for you. Okay, so I got 1 over x cosine natural log x, and I've got minus 1 over x sine natural log x. Okay, and I want x squared of this guy, and I want minus x of that guy, and I want 2 of this guy, and when I get done I better have 0. Alright, so that's my plan. I have 2x sine. I have minus x sine. I have another minus x sine. Boom, boom, boom. They go away. I've got minus x cosine. I've got plus x cosine. Boom, boom. They go away. I get 0. Check. Okay, 12, 14, 16. Now, 16 is everything that you want to know about Chapter 2. Everything is in problem 16. So understanding problem 16, if you understand that, then you understand all of Chapter 2. We can just skip it, go right to 3. No, I guess we won't do that. All right, so we've got a differential equation, 3y double prime plus 3y prime minus 4y is equal to 0. And it'd be nice if this wasn't a pi there, right? All right. And we're going to say that y, we're going to guess the solution. Y is equal to r, is equal to e r to the x. E r to the x. Okay. And then we're going to find what values of r would solve this equation. Alright, so y prime would be r e to the rx, and y double prime would be r squared e to the rx. And then we say, well, I've got 3 r squared e to the rx plus 3 r e to the rx minus 4 e to the rx is equal to 0. Okay, so I just put those guys back up there and wrote them across there. Is e to the rx, is that ever 0? Does e to the rx ever go to 0? No? Okay, so I can divide by that. So if I divide by e to the rx, then I can have 3r squared plus 3r minus 4 is 0. Is that what I have? Yeah, that's what I have. And what do I see? I see a quadratic formula. I wonder if it factors. That'd be good, right? If it just factored 3r minus 2 plus 2. That doesn't work, does it? I don't think. Do you think it factors? I don't think it's going to factor. Bummer. Okay, and we can't use the half quadratic formula yet because the thing in front of the r is an odd number, so we can't pull that trick on you. But I will. I will pull that trick on you. Okay, so that being the case, r is going to be minus 3 plus or minus the square root of 9 minus 4 times 3 times minus 4 divided by 6. So r is going to be minus 1/2 plus or minus. Nice, I got 4, 16, 16 times 3. Is that 48? 48 plus 9, 50. The square root of 57?
Yep.
Over 6. I don't think the square root of 57 is a prime number, isn't it? Yeah.
Yep.
So anyway, that's the value of R. All right. So, but what is this telling us? This is telling us that anything in that condition could be done that way. You could skip all those steps. You could call this your characteristic equation. And we do. We call that we skip all the steps, go from the differential equations to this, which is our characteristic equation. We then have the answer of that. So our answer is going to be y1 can be e to the minus 1/2 minus the square root of 57 over 6 x. And the second guy could be e to the minus 1/2 plus square root of 57 over 6 x. So we could do that. All right, skipping 18, going to 20. Now sometimes it helps to read the problem, and sometimes it doesn't. Just confused by the facts. In these problems, verify first that y of x solves the differential equation, and then find c. Okay, so that's all we're going to do. So I've got y prime equals x minus y. And we say that y is equal to c e to the 7x plus x minus 1. Okay, so y prime would equal minus c e to the minus x plus 1. Okay, so now does minus c e to the minus x plus 1, does that equal x minus c e to the minus x plus x? The minus sign goes like that, minus 1. Okay, so I look at that and I got an x, I got a minus x, I got a minus, I got a minus, I got a plus, I got a plus, check. It does. So it does solve it. Okay, now that I know that it solves it, I have that y of x is c e to the minus x plus x minus 1, and I know that y at 0 is 10. Okay, so 10 is going to equal c minus 1. Because I put a 0 in here, giving me a 1, and that's a c, and then I've got a 0 there, minus 1. So that implies very strongly that c is equal to 11. So for my final answer, I'm going to write, what am I going to write? If I could see more, it would be helpful. That's the only problem. 11 e to the minus x plus x minus 1. Okay, that's 20, skipping 22, going down to 24. Oh, you gotta be kidding me. What a pain. How they get worse, don't worry about it. No, 24. Get used to it. Yeah, that's right. So xy prime minus 3y is equal to x cubed, and I've got that y is equal to c x cubed plus x cubed natural log x. Okay, I'm going to verify that this is in fact the right guy. Okay, so y prime 3cx squared plus 3x squared natural log x plus x squared. Right. And if I take x of those guys and I take minus 3 of these guys, I'm supposed to get x cubed back. That's what I'm supposed to get. Okay, so minus 3 plus 3 x cubed x squared times x. That guy goes away. I've got minus 3 plus 3 x cubed x cubed. Those guys go away. The only thing I have left over is x squared, which checks. So my solution does check. That's a good thing. My initial...
How would x cubed equal x squared?
Oh, this x cubed here, is that what you're talking about? Is that better? Because I have x times x squared giving me an x cubed. Yeah.
Where does the x in front of that 1y come from? Oh, never mind. I got where you're from.
Isn't that great? It is so, it's really cool because in a normal class, no one could see that, right? Unfortunately, you guys are marginally intelligent and you can figure it out, right? Before you can answer, before you even ask the question, you can figure it out, right? All right. No matter how devious and slanted I might be. I'm not done with that one yet. Don't go away. Come back. All right, so we still have the other part of the problem to do, which is, this is 24, right? So y at 1 is 17. So y at x is x cubed c plus natural log x. Y at 1 is 17 is equal to c, implying c is 7. That's sort of redundant, right? So final answer, y of x equals x cubed 17 plus natural log x. We call the guy with the c in it, we call that a general solution. The guy without the c in it, we call that a particular solution. Okay? Because this guy could be 1,000 different solutions. Any c at all will work. Okay. Skipping 26, going to 28. Now this is where we start getting a headache. Because that's just the nature of the game. But luckily I'm doing problems. Now these are in the back of the book. You could look if you wanted to. The line tangent to the graph y at the point xy intersects the x-axis at the point x over 2, 0. Doesn't give you a headache already? Yeah. Okay. Okay, so I got some graph. Okay, so there's my graph. No, there's my xy axis. I have some graph. There's my graph. I got some point. That's x and y. Okay. And the tangent to the graph y. Okay. So I've got some slope at that point, right? So y prime is the slope, and it comes down like that, and it hits here. Oh, it doesn't hit there. It hits, oh, bad picture. Okay, we'll go and we'll move this guy like that. Okay, we'll move that guy. So now he is over here. Okay, there we go. Now it hits there at x over 2. Okay, see how that works? All right. So what is that trying to tell me? The line tangent to the graph G at the point xy intercepts the x-axis at the point x over 2, 0. Okay. In the problems, a function x is described by some geometry. Write the differential equation having the form blah, blah, blah. Okay, we're not solving it. Okay, write a differential equation of the form blah, 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 having the function g as its solution or as one of its solutions. Okay, so the function g is this graph out here. All right, so we have, let's see, we have the thing that's y is equal to mx plus b, right? But then we have the other one that says y minus y1 is equal to the slope x minus x1, right? The point intercept form. Okay, so we're going to use this form and say that y minus 0 is equal to the slope g prime x minus x over 2. Okay, so I'm going to have y is equal to g prime times x over 2. Have we done what we're supposed to? Write a differential equation in the form blah, having the function g as its solution. Yeah, I think we're there. You think we're there? If I put a green mark check, then it must be true. Okay, excellent. 28, 29, 33, 32. 32. Now, you're supposed to do odd starting with 1, right? So that means you go all the way to number 50, 48, right? No. You only go as far as I go. So if I can't solve 32, then you would stop before 32. Okay. The time rate of change of a population, change in population, change in time, is proportional to the square root of the population. Now, in the matter of blah, 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 a differential equation that is a mathematical model of the situation. When I take away the proportional sign, what do I have to do? dp dt equals k, some constant of proportionality. Square root of that. Done. Boom. Should have done that in green, but.
Where do you get k from? Like, how do you?
Oh yeah. Now you're moving all the way back to algebra 1. Yeah. So if A is proportional to B, that means that A is equal to some constant of proportionality times B, right? Yeah, you don't remember that?
I don't, honestly.
Ooh, bummer. Yeah, so 2 is proportional to 4, right? 2 is equal to 2 times 2.
Oh.
Constant of proportionality times B. 1/2 times 4. Okay. Yeah, so that's something that goes all the way back to algebra 1. things are directly proportional, things are indirectly proportional.
What would you do if it's indirectly proportional?
Well, if A was inversely proportional to B, it'd be written like that, and A would just be equal to K over B. Yeah. Yes, Virginia, we will cover every single piece of math trivia ever cited in the world before the end of today. No, maybe not. Okay, number 36. In a city with a fixed population P, the time rate change of the number N of those people infected with a certain contagious disease is proportional to the product of the number who have the disease and the number who do not have the disease. Okay, obviously there's too many lines of print there and it's too small. The time rate of change, dN dt, of the number infected, so N is the number infected with a certain contagious disease, is proportional to the product of the number who have the disease, N, times the number who do not have the disease, P minus N. Okay, so dN dt is equal to K, some constant of proportionality, N, P minus N, and I'm done. Well, those are pretty simple. I mean, those are only one-liner thingies. 36, 38, 40. All right, 40 says, determine by inspection at least one solution. Oh, well, that's good. I mean, if we're going to have problems where all we're going to have to do is just by inspection write down the answer, I might be able to pass this class, right? So y prime squared plus y squared is equal to 1. Okay, anybody tell me what that answer is? Y is equal to... Okay, tell me an equation that's equal to 1.
Minus 0.
1 minus 0 equals to 1. Okay, that was trivial if I ever heard of one. Tell me another equation that's equal to 1.
Minus 1.
Hmm?
2 minus 1.
2 minus 1. Another trivial condition. Tell me another one. Go back to your trig class. Tell me an equation, a trig equation that's equal to 1.
Cosine squared plus sin.
Oh yeah, cosine squared plus sine squared is 1. Yeah, that's right. So if y were sine, or if y were cosine, then this guy works, right? Yeah. So yeah, it's there. It's in the back of your mind. So by inspection, I have two solutions, sine and cosine. Okay, good enough? 44. 44. Well, I goofed off a little bit before we started, right? So we're going to have to get out of section 1 pretty soon so we can go to section 2. 44. Well, if I do 44, I have to go back to problem 43. Okay, I guess we're done. Done with 1-1. All right, so now I'm going to start section 1-2.
So we can do through 43 or through 49.
Yeah,
Or
yeah. Let's see, what did I do? I made it to 36, so you can stop wherever you are before 36. Yeah, or you can do more. I mean, the problem with this is the problem with doing more. The book is used in both undergraduate and graduate classes, so you don't want to go and do problems outside of the assigned text. So because the stuff at the back of every section is made for a graduate student who's already got a bachelor's degree in math. Okay, so you want to stay away from that. Okay, is that clear? Mm-hmm. Now the Andrew on this side will only solve, he'll start at the back of the book. He'll start back of the section working forward until he gets to the easy ones. Because that's what he's going to do. Anyway. So I have a general solution and I have a particular solution. This is English. So a general solution, y is equal to cx. A particular solution, y is equal to 4x. So this is general. This is particular. If I could spell particular. All right, so we have English things going on. We notice that we can solve weight problems because weight is mg, mass times g, and gravity is an acceleration. And isn't that lovely? Okay. So basically the English in front of the problem set is totally useless. I started at number 4 last time, so I'll start at number 2 this time. Number 2, find the function satisfying the given differential equation and the prescribed initial condition. Okay, so number 2, dy dx is equal to x minus 2 squared, and y at 2 is 1. Right. Now, I have no way to solve that initial condition. So find the function y satisfying that. Okay, so I'm going to separate my variables and say y dy is x minus 2 squared dx, and then I'm going to integrate both sides of the equation, and I'm going to say y is equal to. Okay, so now I'm going to go and I'm going to guess that my answer is in the form x minus 2 cubed, and the derivative of my guess would be 3x minus 2 squared. So if I multiply this times 3 and that times 1/3, I really don't have to do that, do I? That's really too much work. Okay, so I won't do that. I'll just say y is equal to x minus 2 cubed over 3 plus c. Yeah, I'll just do that. This is way too much work. Get rid of that. Next time I'll use a bigger eraser. Okay, now that I know that, y at 2 is 1. So that sort of implies that c is equal to 1, because when I put a 2 in there I get a 0. So final answer, y of x equals x minus 2 cubed over 3 plus 1. All right, skipping forward, going to 6.
How is y of 2 equal to 1? Isn't 2 minus 2 0? And 0 cubed divided by 3 would be 0?
Okay, the initial condition says y at 2 is 1. So when I put a 2 up here, I get a 2 minus 2. That becomes 0. So 1 has to equal c. Okay, so I'm putting a 2. I'm saying y of 2 which equals 1 is going to equal 2 minus 2 squared over 3 plus c. This becomes 0, c becomes 1. Yeah, that's the step I skipped. The skip I stepped? Yeah. And we're going to look at number 6. dy dx equals x square root of x squared plus 9, and y at minus 4 is 0. So that's what I've got. And I'm going to rewrite that. dy is equal to x squared plus 9 to the 1/2 dx, and then I'm going to integrate both sides of the equation. I'm going to skip a whole lot of steps and say y is equal to x squared plus 9 to the 3/2 times what? Divided by 3? Divided by 3 plus c. Okay, and then I'm gonna check it. Normally I'd guess what the answer was and then do it the other way, but this time I'm just gonna. So I'm gonna take the derivative of y. The derivative of y. I have 3/2 x squared plus 9 1/2 times 2x divided by 3, which is x square root of x squared plus 9. So I got the right thing. All right, so I checked my work. I got the right thing. I'm going to apply the initial condition. Did I even write down the? Yeah, I did. I wrote down the initial condition. So y at minus 4 is supposed to be 0. Okay, so I come back up and minus 4. So minus 4 squared. So that's 25 over 3. And 25 is raised to the 3/2 plus c is supposed to be 0. Okay, so the square root of 25 is 5. 5 cubed is 125. So it's 125 over 3 plus c is 0, implying that c is equal to minus 125 over 3. So now I'm ready to write my final answer. Final answer. Y of x equals, anybody remember? X squared plus 9 to the 3/2 divided by 3 minus 125 over 3. Okay, good enough? All right, that was 6, skipping 8, going to 9. All right, going to 10. I am disappointed. We haven't had any hyperbolic sines or cosines yet. They're not even on this page. That's disgusting, isn't it? dy dx equals x e to the minus x. Y at 0 is 1. Okay, so dy is x e to the minus x dx. Integrate both sides. I get y of x equals, bummer. Integration by parts, right? Yeah. All right. Well, we could probably look in the back of the book and get the answer right. It'll probably tell us the integration by parts those cycles. Let's see. Do we have an x e to the x? No, do we have an x e to the minus x? Yeah, as I was saying, integration by parts. So, uv prime is equal to u prime v plus v prime u, right? Okay, so u prime v is equal to u v prime minus v prime u. Okay, and then I integrate, boom, boom, boom. So again, the integral of u prime v is uv minus the integral of v prime u. Okay, so I'm all set. And now I have to pick what I'm going to pick. So I'm going to pick x is going to be v. So v is equal to x, v prime is equal to 1. Okay, so v is equal to x, v prime is equal to 1, u prime is equal to e to the minus x, and u is equal to minus e to the minus x. Okay, so now we're all set. So the integral of x e to the minus x is equal to minus e to the minus x minus the integral of minus e to the minus x. Oh, okay, so that'd be minus e to the minus x, and I'm not in alphabetical order, so that's bad. The integral of x e to the minus x is going to be e to the minus x, right? And then minus e to the minus x, so it'll be minus e to the minus x. Okay, that being the case, y of x is equal to that, plus c. Right. Now, do we have an initial condition? Y at 0. Why don't we check our work? Mainly because Andrew doesn't believe us. Okay, so we're going to check our work. Y prime is equal to minus e to the minus x plus x e to the minus x plus e to the minus x. Check. So our answer checks, everything's fine. Now I can go back to what we're doing. Okay, so y at 0 is 1. Okay, so y at 0, that becomes a 1, that becomes a 0. I got a minus 1 plus c, implying that c is equal to 2. So for my final answer, I'm going to have y of x equals minus e to the minus x, minus x e to the minus x, minus e to the minus x plus 2. Good enough? All right, 10, 12, 15, 14. Okay, so we're going to do 14 next. Okay, so acceleration is 2t plus 1. And all we want to do is find the function x of t. Okay, so dv dt is 2t plus 1. dv is 2t plus 1 dt. Integrate both sides. Also, I know that v at 0 is minus 7 and x at 0 is 4. So those are the initial conditions. Of course, I'm going to forget what they are when I get. So v is equal to t squared plus t plus the initial condition of v0, which is minus 7. This is change in position, change in time. So change in position, t squared plus t minus 7 dt. Integrate both sides. Position at times t is t cubed over 3 plus t squared over 2 minus 7t plus x of 0, which is 4. Now, because the book uses x of t, and in your physics classes you always used s, right? Yeah, the calculus book uses x. So for our final answer, we'll write it the way the author wants it. Position, x direction, at t, t cubed over 3, t squared over 2, minus 7t plus 4. That's 14, 16, 18 is next. Acceleration is a sine wave? Yeah, it would be. Yeah, you have a spring going up and down, and the acceleration is a sine wave. Okay, not a problem. Number 18. Acceleration at times t, 50 sine 5t. Okay, so dv dt, yeah, dt. 50 sine 5t. dv 50 sine 5t dt, integrate both sides. Velocity at times t. 250 cosine 5t plus the initial condition, which is minus 10. Okay, which is change in position, change in time. So change in position, 250 cosine 5t plus minus 10 dt. You see any patterns here? Integrate both sides. Position, final answer, position at times t. Minus. Oh, take the knife out of my back. Okay, as I was saying, the integral of 50 sine 5t is 5 cosine 5t, right? Say yes. Yes, it is. And the integral of 5 cosine 5t is going to be minus sine 5t. No. This is 10. Is this 10? And this is 10. And then this is 2. So that's 2. No, that's still 10. That's still 10. But this is 2. Right? This is still 10. Boy, is that ever messed up? 10. 2. Sine 2t. Minus 10t plus the initial condition, which is 8. Plus 8. Done. Done. 18, 19, 20, 21. Okay, I got to do 22. And then I don't have to do 22. We could, but there's no football games on anymore, right? So no reason going home or anything. Figures 19 to 22. A particle starts at the origin, travels along the x-axis with the velocity function y of t, blah, 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 blah. Sketch the graph of the resulting position function. Okay, so that's what we're going to do. All right, so here we go. This guy goes that way, he goes that way, he goes that way. Okay. This is 4. That's 7. This is 10. That's 0, and that is 5. Okay, now we're going to do a position thingy. And this is v of t. V of t.
That 4 should be a 3.
Huh?
That 4 should be a 3. Is that 3?
Yeah, that should be a 3. I agree. So that should be a 3. Okay, so my slope is what's that slope? 5 over 3. So that curve right there, y is equal to 5 over 3x. Okay, that's the slope. 5 over 3x. Okay, so that my velocity at times t is 5 over 3t. My position at times t is going to be 5 over 6t squared. Okay, so 5 over 6t squared. So at 1, I'm going to be 5 over 6. Right there, 5 over 6. At 2, I'm going to be 5. I'm going to be 20 over 6. 20 over 6. 10 over 3. Okay, so here I am at 10 over 3. So I was here. Now I'm there. When I got 9, where's my calculator? It's too late in the day to be doing it in my head. Okay, so I got 5, 6 times 9. 7.5. So now I'm going to be here at 7.5. So I have a thing doing that. Now, across here, my slope is 0, right? So, but I'm going to have a slope across. I'm going to run out of room. Darn. So for 4 of these guys, I'm going to be at 5. 4 times 5 is 20. So that means I'm going to go in a straight line up to 20. Okay. Now my slope is negative, but it's the same slope as I had that way. So I would come down like that, and I'd be 7.5 below the 20. So we're 7.5 below the 20. That's right there at 12.5. There, we did it. It looks pretty ugly, but we did it. That was almost a 8th grade thing. I almost skipped it. 24:26. A projectile is thrown straight up. All right. Should we do that one, or is that too much of a physics problem? 30. A car is skidding. We want to do, let's see, a car. Suppose a car is skidding. We're dropping a ball. A person throwing a ball straight up. A stone. Suppose a woman jumps. A car. You drop a bomb from an airplane. That sounds like fun. Or should we? Yeah, we'll do 41. Okay, 41.
What does it say in front of like the 5/3 t right there? There you go. What's in front of like e? What
That's
is
v of t.
V of t. Oh.
Yeah, the velocity. The velocity for that portion of the curve doing this, doing that, the velocity is equal to velocity at times t is equal to the slope times time. And the y-intercept is 0. So that's why there's nothing else there. Okay, so we're going to do 41, and then we'll call it a day. Unless we find a more difficult problem. And 41 is sort of like a bomb is dropped from a helicopter hovering at an altitude of 800 feet above ground. Okay, so I got a helicopter, okay, and 800 feet, and there's my ground. I got it. From the ground, directly beneath the helicopter, a projectile is fired straight towards downward. Okay, a projectile is fired straight upward towards the bomb. Okay, so I've got something here, and I'm going straight upward towards the bomb, and right here I have the bomb coming straight down. Exactly 2 seconds after the bomb is released. Okay, so this happens at t equals 0, and this guy happens at t equals 2. With what initial velocity should the projectile be fired in order to hit the bomb at an altitude of 400 feet? Okay, so at 400 feet, we're going to meet. Okay. Is that good enough? Did the picture okay? I think it's time to drink my Coke Zero. Okay, so we'll start with the bomb. Acceleration of the bomb is minus 32 feet per second squared, which is dv dt. So velocity at times t, after I separate variables and do everything I need to do, minus 32 t plus initial velocity of the bomb, which is 0. Okay, so which is the position, change in position, change in time. So change in position minus 32t dt. I integrate both sides, and I got my position at times t is going to be equal to minus 16 t squared plus 800. Okay, now we know that. Now, the position of the projectile coming up. So my acceleration is still minus 32 feet per second squared because it's still affected by gravity. Okay, which is change in velocity, change in time. So change in velocity is equal to minus 32 feet, or minus 32, we'll drop the feet per second because that's clouding my mind. 32 dt, I integrate both sides, and I get my velocity at time 2, at time t, at time t minus 2. T minus 2, because I don't go up until t minus 2, is going to be minus 32t plus the thing I'm solving for, v naught. Okay, which is change in position, change in time. So I got change in position is equal to minus 32t plus v naught. Yeah, I don't know that I like this. dt. So I integrate both sides, and I get position at times t minus 2, because I take off later, is going to be minus 16 t minus 2 squared plus v naught t minus 2 plus initial condition, which is initial position, which is 0. Okay, now these guys are going to be equal at 400 feet. They're both going to be at 400 feet. Okay, they can only be equal at 400 feet, right? Okay, so minus 16 t minus 2 squared plus v naught t minus 2 has to equal minus 16 t squared plus 800 plus 800. Now I could set them both equal to 400, solve for t in that one and put them back here, or I can set them equal. I think I can set them equal, can't I? Minus 16 t squared plus, what is 4 times 16? 68? 64? 64, right? 64t minus 64 plus v naught t minus 2v naught is equal to 16t squared plus 800. I don't think this is going to work, because I have one equation, 2 unknowns. So I'm not going to do this. What I'm going to do is something different. I'm going to say that minus 16t squared plus 800 is going to be 400, which is 16t squared is going to be 400, which is t squared is going to be 400 divided by 16. T is going to be 20 over 4. So at 5 seconds, I'm going to be at 400 feet. Okay. Now, the second equation is that minus 16 3 squared plus v naught 3 is going to equal 400. Okay. So v naught is equal to 400 plus 9 times 16 divided by 3. At that point, we take out our calculator. 400 plus 9 times 16 equals, divided by 3, 188 and 1/3 feet per second is what I must fire the projectile at. Now, we will look in the back of the book. If that's the correct answer, we'll go home. If not, we'll stay here until we get it right. Okay, does that seem good? Maybe, I don't know, I'll depend. I'll decide that later. I don't have to make decisions right away. Right? So problem set 1 1, 2. Okay, so we're looking at 41. Oh, look at that. Ooh, 181.33 feet per second, which is clearly 181 and a third. So we got it right, so we can go home. Any questions? That doesn't seem too bad, right? Oh. And like I said, you do the homework, life will be wonderful, and everything will be good. Control, Alt,